Welcome to our exploration of functions in Unit 3. In this unit, we're diving into array and string functions that empower you to transform data tailored to your specific needs. You'll start by understanding each function individually and gradually learn to integrate them for optimized workflows. We'll cover a range of functions, including merge, first, split, replace, and length. Additionally, we'll revisit some foundational functions like map, sort, and sum. Think of these as building blocks. Each one has unique features that, when combined, create powerful and efficient data solutions. By mastering these functions, you'll be able to create complex formulas that significantly adjust your data while consuming fewer operations. This efficiency is key in handling larger data sets or more complex analysis tasks. Let's embark on this journey to elevate your data manipulation skills and unlock new possibilities. Ready to get started? Let's go. Let's dive into an exciting real-world example that will help us explore new functions. Meet Sharmila, a data analyst who is eager to start her first project using Make. She's been given the task of creating a sales report for a large bookstore chain spread across multiple regions. Her project involves gathering key data, the name of each store in the regions, identifying the top salesperson in each location, and highlighting the most popular books sold in each store. Beyond these specifics, her client is looking for comprehensive insights, such as the total number of bookstores, the collective revenue generated, and which individual stands out as the top salesperson across all locations. This might sound like a lot, but it's perfectly manageable with the right functions. Through this project, we'll see how these tools can elegantly organize and convey valuable information, making Sharmila's analysis not just feasible, but efficient. Let's get started on achieving these goals together. In this project, Sharmila is tapping into a data API to analyze sales performance across various regions. The key focus here is on making requests to gather data efficiently. Since she's dealing with two regions, each having a couple of stores, the process involves requesting the API once per region. This setup allows for streamlined data retrieval, emulating real-world scenarios where targeted queries help manage resources and complexity. You're encouraged to replicate Sharmila's approach. This involves building a report from scratch, using functions that will guide you through the process. As you proceed, you'll learn new techniques and methods to enhance your data analysis. Start by creating a scenario from the provided template and naming it Make Intermediate 6 to 2 inches. Running this scenario will grant you an insight into the data structure you'll be working with, acting as a blueprint for your project. This step ensures you're well equipped to understand and manipulate the data effectively as you build your report. In this lesson, we're diving into the specific goal of Sharmila's project. You'll be working with mock API data, which serves as the central hub of information. This data includes all the key details from each region Sharmila is analyzing. Your task is to transform this raw data into a clear and insightful report. Our aim is to not just extract data, but to understand and organize it in a way that highlights important trends and insights, just as Sharmila has done. Think about how this report can inform business strategies and decisions. As you explore the elements of the API data and the final report, consider how each component plays a role in achieving an accurate and meaningful analysis. Let's unravel how these pieces fit together, enabling you to create a detailed and comprehensive report. Understanding how to parse JSON output is crucial for organizing data effectively. Here, each Parsi JSON module represents a distinct region, and within each region, you'll find an array containing information about two stores. For each store, we capture key details: the store's name, its revenue, the top salesperson, and the top selling book. The top salesperson is not just a name, it includes a collection of information such as the person's name and the number of books they sold. This helps in identifying who drove the most sales. Similarly, the top selling book is more than just a title. It's a collection that provides details like the book's title, its identification number, and the number of copies sold. This comprehensive data structure allows you to understand both sales trends and individual performance across regions, setting the stage for generating insightful reports. In this section, we are focusing on the culmination of our data analysis, producing a concise and informative report. The primary goal is to extract and summarize key information from your data sets. You'll need to determine the total number of bookstores, sum up the entire revenue they generated, and identify the top performing salesperson by the number of books sold. The objective here is to streamline the data into an easily digestible format. We have 4 bookstores in total, contributing to a significant revenue sum of $58,702.77. Among the sales team, Dwayne emerges as the top salesperson, recognized solely by his exceptional book sales. This report will serve as a foundational layer for more detailed analysis in the future, providing a clear snapshot of performance metrics that are vital to business assessments. By focusing on these critical components, you set a strong precedent for evaluating store success and individual contributions effectively. To kick off building this use case, we need to focus on collecting the right data. It's crucial to merge information from different regions to see the bigger picture. Each JSON module outputs separate arrays for Region 1 and Region 2, representing different stores. To handle all of this data effectively, you'll want to combine these distinct arrays into a single unified array. This is where the merge function steps in. It's a handy tool that simplifies this process. By merging, we bring together data from both regions, making it easier to generate a comprehensive report. Think of it like gathering pieces of a puzzle. Merging helps us see the complete image. Once you've got everything in one place, you're all set to dive deeper into analysis, ensuring no detail is overlooked. Once you've successfully parsed the data from both regions, the next step is to merge these datasets for a comprehensive overview. Begin by using a set variable module to create a variable named merged_stores. This will neatly hold the combined data from both stores. In the variable's value, type the merge function. You'll include and separate the arrays of the 2 stores with a semicolon inside this function. Don't forget to properly close it with a parenthesis at the end. Otherwise, it won't operate as expected. Once you execute the scenario again, you'll notice the output will now show 4 items within the array. Initially, there were 2 separate arrays, each containing a pair of items. By merging them, you now have a singular cohesive array. This process not only simplifies data handling, but also sets the stage for any further analysis or reporting. You can also view a demo to better understand how the merge function operates in this scenario. By doing this, you ensure all data is efficiently organized and ready for the next steps in your project. Now let's focus on getting the top salesperson's name, which is the trickiest part of this unit. First, you should simplify the data you're dealing with, so let's start by generating an array only with the salespeople information. You can do that using the map function, which you've learned about already if you've done all the courses in the Academy. By mapping the top salesperson collection, the new array will contain the values of each collection, the name and books sold. Give it a try on your own. We'll explore the answer on the next page. To effectively use the mapper function, let's delve into the process of creating the top salesperson array. This array specifically targets and extracts the names of top salespeople from a larger, more complex data set. You start with a variable named top salesperson array, which is designed to exist only for one cycle, meaning it's temporary and only necessary for this phase of processing. Using the map function here is crucial because it simplifies this task into a streamlined operation that focuses solely on the top salesperson key within each collection in merged_stores. A complex array like merged_stores holds various elements such as sales data and individual salesperson records. The map function efficiently navigates through this data set to pull out only the essential information we need, the names of the top salespeople. Remember, each key you use must be precise in its syntax and spelling. This ensures the data returned is accurate and reflects exactly what you distilled from the broader collection. This approach not only enhances the accessibility of your data by breaking it down into manageable pieces, but also optimizes how effectively you can generate reports or further use this information downstream. Now that we've set the stage for our use case, it's time to dive into the scenario. Initially, we had an array structured with multiple elements: store names, revenue figures, collections of top salespeople, and best-selling books. This complex structure might seem overwhelming at first, but it contains valuable data we need. By using the merge and map functions, we've transformed this information into a more focused form. Our new array, top salesperson array, distills the data down to just what we need: the top salespeople. This refined array contains all instances of the top salespeople as a collection. Why is this beneficial? By extracting only the necessary data into a new array, we enhance efficiency and streamline our ability to manipulate and analyze the information. It sets a solid foundation for the next steps, where we can delve deeper into the performance of each top salesperson. Ready to explore further? Let's continue optimizing and uncovering insights from this data. Now that we've created an array to track our top salespeople, our next objective is to identify the leading performer. To achieve this, we can employ two useful functions: sort and first. Start by using the sort function. This function will organize your array based on a specified parameter. In our scenario, that's the number of books sold. By sorting the array from the highest to the lowest number of books sold, you create an ordered list that highlights the top performers. Once sorted, the first function becomes the key to identifying the top salesperson. This function simplifies the process by selecting the very first entry in the sorted array, which represents the top performer in terms of book sales. With these steps, not only do you streamline the process of finding your top salesperson, but you also ensure the data is easily accessible for future needs. Try implementing these functions on your own by naming the new variable top salesperson. We'll explore the solution in more detail shortly. Now that you're on the path to identifying the top salesperson, let's dive into how this is done using the sort function. The objective here is to organize your list of salespeople based on how many books each has sold. By applying the sort function to your top salesperson array, you can arrange the data in a specific order. When you sort, you'll choose whether to display the data in descending from highest to lowest, or ascending order from lowest to highest. In this scenario, you want to identify the top performer, so you'll opt for descending order. The key factor here is the number of books sold. This is what determines the ranking within the array. By implementing this sorting technique, you efficiently prioritize the salespeople by their performance, setting the stage to pinpoint your top achiever easily. To identify the top salesperson in your array, you'll use the first function. This function is straightforward. It simply returns the first element of an array. In this case, we want the top result from our sorted list. The example provided demonstrates how the first function encapsulates the sort function. This is an example of function nesting, where the innermost function is processed first. Here, the sort function organizes the array in descending order based on the number of books sold. Once sorted, the first function then selects the highest value from the list. By nesting these functions, you efficiently streamline the process of retrieving the leading salesperson from your data set. You've worked through the sorting process, and now it's time to check your results. By running the scenario again, you should see that your output matches the expected structure. The data you've been working with is organized into a collection, and from this, you've pinpointed the top salesperson stored under the name top salesperson. Now, although you have this detailed information, your goal is to extract just the first name from this collection. This task will require combining three functions: get, split, and first. These will allow you to isolate and retrieve that specific piece of data. As you proceed, keep in mind that each function serves a distinct purpose. Get accesses data, split divides it into manageable parts, and first helps pinpoint the initial element. With these tools, you'll be equipped to efficiently complete your task. Let's build on this as we move forward in the exercise. Let's talk about how to modify values using the split function. Imagine you have a string of data, like a list of numbers separated by commas. The split function takes this string and breaks it down into smaller parts, turning it into an array of individual elements. For example, if you have the string 1, 2, 3 applying split, with a comma as the separator will give you an array containing three separate items, 1, 2, and 3. This is particularly useful when you want to handle each item individually. In our scenario, you want to extract the first name of the top salesperson. You'll use three functions: get, split, and first. Here's how it works. You'll first retrieve the full name from your data collection using get, then use split to divide the full name into parts, typically separating by spaces to isolate the first name. Finally, first will help you pick out the first element from the array, which should be the first name. Once this is done, you can label this new value as top salesperson first name, making it easy to identify and use later on. Working through each stage carefully will ensure you accurately transform and manage your data. When transforming data, it's essential to break down your goal into manageable steps. Here, we're focusing on extracting the first name from a full name using specific functions. Start by retrieving the full name from the collection. This could be something like Dwayne Maker. Next, use the split function to separate this full name into parts. Think of it like taking a phrase and slicing it up at each space, so you're left with individual words, in this case Dwayne and Maker. To isolate the first name, apply the first function to those separated parts, giving you Dwayne. If you ever need the last name instead, there's a handy last function you can use to grab that directly. Give these steps a try to build your fluency with functions. In this exercise, we're focused on retrieving and modifying values using simple functions. Let's break it down step by step. Imagine you have a data set where each entry includes a top salesperson's full name. Our task is to isolate just the first name. First, we use the get function to extract the name from the top salesperson array. Let's say the full name is Dwayne Maker. Next, we employ the split function. By specifying the space character, we split the full name into separate parts, Dwayne and Maker. This separation allows us to handle each name component individually. Finally, to extract just the first name, we use the first function. This will select the first part of our split result, giving us Dwayne. By taking these steps, we're breaking down complex data into manageable parts, making it easier to manipulate and understand. Always remember the importance of these basic functions in data management. They're the building blocks for more complex operations. You've made great progress so far by using key functions to manipulate your data effectively. First, you've merged two arrays, which allows you to combine data sets seamlessly. This is crucial when working with diverse data sources, as it ensures you have a comprehensive view. Next, by creating an array specifically for the top salesperson, you've set up a dedicated space to highlight and manipulate this important data. Identifying the top salesperson involves filtering your data to focus on high-performing individuals. Once identified, formatting their name ensures consistency and clarity, which is vital when presenting data to stakeholders. Remember, the array you've created will play a pivotal role as you move forward, especially when calculating total revenue in the upcoming steps. You're well on your way. Keep up the momentum. To calculate the total revenue, we start by diving into the process using the map function. Our goal is to extract revenues from our merged store collections. By mapping over these store arrays, we can isolate the revenue figures into a simple array of numbers. Once we have this streamlined data, the sum function comes into play, allowing us to add all these values together effectively. Think of it like transforming a complex jigsaw puzzle into a straightforward addition problem. First, map lets us focus solely on the numbers we need. Then, sum delivers the final piece, giving us an overall total. Now it's time to put this into practice by creating a variable called total revenue. This will store the result of our calculations, ready for use in further analysis or reporting. Don't worry if it seems complex at first. Each step builds on the last, bringing clarity and simplicity. Now that we've set the stage, let's dive into retrieving the first name of our top salesperson and calculating the total revenue. This involves a few handy methods. First, we use the split function, which is perfect for breaking down strings into more manageable parts. You'll need it to isolate the first name from a full name entry. Next, calculating the total revenue requires using the map function. This helps us target the revenue data across all merged stores. Once we've mapped out these values, the sum function will add them up neatly, simplifying the data into a single actionable figure. This is where the variable total revenue comes into play. This variable holds the sum and is designed to last just through this particular cycle of calculation. If everything is set correctly, the output should be a precise total of 58,702.77. This figure not only validates our process, but also equips us with the critical insight needed to evaluate performance effectively. Let's ensure these steps give us the clarity needed as we move forward. Let's move forward by focusing on generating the final report. At this stage, you need to determine the total number of stores within your merged data. Each item in your merged _stores array represents a single store. By counting these items, you can easily identify the number of stores involved. To achieve this, you'll use the length function. This convenient tool calculates how many items are present in your collection, providing you with the number you need. Once you have this value, consider using either the compose a string or set variable module. This step is crucial as it helps prepare the final output, which you can then include in your report. Remember, the goal is to smoothly integrate this information into your final document, ensuring that it's complete and ready for distribution. Keep up the great work. Fantastic progress on generating your report. Now let's focus on neatly organizing the output. By adding a text label, you can clearly identify the total number of bookstores. Use the T merged _stores item to keep your data structured. This approach not only enhances readability, but makes the information more intuitive for your audience. After running the scenario, your report will display the total bookstores as expected, providing a clear and professional summary. Keep going step by step to ensure a coherent and refined output. Now let's dive deeper into effectively generating your report. You'll want to make sure each piece of data is clearly labeled. This clarity helps not only in organizing your content, but also in making it easier for your audience to understand the results at a glance. First, we have the number of bookstores, which is calculated using the length function on the merged stores item. This function provides a straightforward count, ensuring you know exactly how many locations are included. Next, there's the total revenue. It's critical to present this figure clearly, and you may want to format it to make the number easier to read. Using the format number function can help tidy up large numbers, adding commas for thousands, for instance, so it's immediately apparent how much revenue is being discussed. Lastly, identify the top salesperson by mapping their first name. This recognition not only highlights outstanding performance, but also personalizes the data, making it more relatable. By creating clear labels and neatly formatting your data, your report will be both professional and user-friendly. This approach not only communicates the necessary data effectively, but also adds a layer of polish to your work. Fantastic work getting this far with the report. Now let's focus on refining it to ensure it looks professional when shared. One helpful feature is setting up an automated email to distribute the report. In this case, Sharmila opted for Gmail to draft the email. A common issue you may encounter is that your beautifully formatted content appears as one long, unbroken line. This occurs because Gmail and similar modules process emails in HTML, which ignores simple line breaks. To overcome this, you can make your report visually appealing by replacing plain new lines with the HTML line break tag. This small adjustment transforms your single line output into a clean and organized email, making it much easier to read and understand for your recipients. Remember, small details like this can make a big difference in ensuring effective communication. In this part of our report, we're focusing on using the replace function effectively. The aim here is to ensure our data appears correctly, especially when viewed in HTML format. Let's break it down. Imagine we have a list of key data points: the number of bookstores, total revenue, and the top salesperson. Without proper formatting, these details may run together in a single line, making it hard to read. This is where the replace function comes into play. By setting it up to detect new lines and substituting them with an HTML line break tag, or we ensure each piece of information gets its own line. This makes the report visually clean and easy to digest. This small adjustment has a big impact on the clarity of the report, especially when viewed in email or web formats. Now, with these tools, you're ready to generate a well-formatted, professional report, sending all your hard work seamlessly through email. Great job so far. Let's keep up the momentum. Fantastic progress. Now that you've built a comprehensive scenario, it's time to see your work in action by checking your Gmail drafts. This should include a report summarizing your key metrics. For instance, your scenario covers 4 bookstores, generating a total revenue of nearly $59,000, with Dwayne leading as the top salesperson. This report showcases not only the data, but also your ability to transform complex information into a clear, concise format. Before we wrap up, let's take a moment to recap the essential points to ensure everything is crystal clear. Let's take a moment to revisit the use case we've built with Sharmila. This process helps us manage and analyze data from multiple stores efficiently. We start by handling data separately for 2 individual stores. These represent sources where the data is initially parsed and structured. Next, we merge this information, creating a unified view that combines input from all stores. This step is crucial for seamless data integration. Mapping all top salespeople allows us to identify key performers across the stores, while finding the top salesperson pinpoints who leads in sales. Extracting the first name is a small yet significant step for personalized engagement. Summing up total revenues gives us the financial overview needed, culminating in the generation of a comprehensive report. This report brings together all our insights, showcasing the performance and helping Sharmila make informed business decisions. Each stage is interconnected, ensuring a smooth flow of information. This thorough process not only aids in efficient reporting, but also enhances strategic planning. In Sharmila's use case, we begin by examining data from 2 distinct stores using the Parsi-JSON modules. Each module holds detailed information about the stores, such as sales figures and inventory. Imagine each store as a collection of various data points, all neatly packaged within a region, which we can think of as an array. This setup allows us to efficiently organize and manage complex data sets, making it easier to perform further analysis or reporting. Understanding this foundational step is crucial as it sets the stage for more advanced data processing tasks in the use case journey. Now let's explore the next step in Sharmila's use case. This module focuses on using the merge function. This function is essential for combining data from two different stores. Picture it like bringing together information from various branches into a single cohesive list. Here, we're merging the data from two regions into one array, which consists of four distinct collections, each representing a store. So you have region 1 with two stores and region 2 with another two. By merging them, you gain a comprehensive view of all stores in both regions, making it easier to analyze and manage the data collectively. This powerful capability allows for more efficient data processing in subsequent steps, setting the stage for further analysis and insights. Now, let's take a closer look at how we identify the top salesperson in our merged store data. Previously, we merged arrays from different regions. Now we use the map function to sift through this merged array and gather details on the top salespeople. Specifically, we pull their names and the number of books they sold. This information forms a new array aptly named the top salesperson array. Essentially, it condenses the crucial data we need to focus on individual performance across our combined store data sets. This step is vital for honing in on the highest achievers and sets the stage for further analysis. In this session, we're diving into the process of identifying the top salesperson from our data set. We're using two powerful functions, first and sort. The sort function is crucial here because it arranges our top salesperson array in descending order based on the number of books sold. Why descending? Well, that ensures that the person with the highest sales ends up right at the top of the list. Once sorted, the first function comes into play by quickly retrieving the top entry from this sorted array. This neatly extracted data is saved into a variable we've named top salesperson. This variable holds a collection of details including the salesperson's name and their total books sold, making it easy for us to access and use this information later. This approach streamlines our ability to spotlight top performers efficiently. Now let's explore how the get, split, and first functions work together to handle the top salesperson variable. First, the get function is used to retrieve the value we're interested in. Think of it as accessing specific information from a database, simple and direct. Once we have this value, the split function comes into play. It identifies the name field and divides it into two parts whenever a space is found. This is exceptionally useful for breaking down full names into first and last names. Finally, the first function steps in to extract the first part of this division, the first name. In our example, this sequence of operations results in extracting the name, Dwayne. These functions streamline data handling and ensure accuracy in retrieving and processing specific data points. In this section, we explore how the map and sum functions work together to streamline data operations. The map function is utilized to sift through the merged underscore stores array, identifying the revenue fields within each collection. Initially, this yields a set of individual revenue values. Think of it as receiving separate reports from each store. Now, without any further processing, these values would simply exist as a list, reflecting the revenue of each store independently. However, when we apply the sum function, it takes those individual figures and calculates a combined total. This process generates the total revenue variable, which gives us a comprehensive view of the revenue across all collections. It's an efficient way to consolidate data, offering a clear insight into overall performance. In this step, we focus on summarizing key details from the module. First, we determine the number of bookstores included in our data. By using the length function, we find that there are 4 bookstores in total. This simple yet crucial step helps verify the completeness of our dataset. Next, although optional, we can format the total revenue to enhance readability, transforming the number 58,702.77 into 58,702.77. This makes financial data more digestible at a glance, especially important in reports. Additionally, we map the top salesperson variable, ensuring we identify and highlight the highest performing individual across all stores. By encapsulating all these outcomes within a single value, we achieve streamlined data management and efficient reporting. This holistic view supports informed decision making and strategic planning. We're wrapping up Sharmila's use case with the final step, creating a draft report using the Gmail module. While it's convenient to send emails instantly, preparing a draft first ensures the entire process is flawless before hitting send. This cautious approach helps prevent errors and ensures you deliver a polished message. To enhance the report's readability, we use the replace function. This neat trick swaps out plain new lines with HTML formatting, giving the report a professional look. And with that, you've successfully navigated through the case and mastered the key functions in this unit. Well done. Your skills in handling these functions have truly grown, setting a solid foundation for future projects. Keep up the great work. The great Congratulations on completing this unit. You've explored a variety of functions and seen how they can streamline operations to prevent scenarios from becoming overly complex. By now, you should have a solid grasp of key functions like merge, first, split, replace, and length, each an essential tool in your kit. Functions may initially appear daunting, but they are incredibly powerful for solving problems. Instead of piling up actions, you can make scenarios lean and efficient. It's rare to encounter a real world situation relying solely on one type of function, whether arrays or strings. Understanding a mix of functions broadens your problem solving approach. Feel free to take a well deserved break, or if you're eager to learn more, dive into Unit 4 to discover new functions and refine your scenarios further. Great job, and keep up the momentum.